The next subtopic in Chapter 3 is 3.2 Conservation of Linear Motion. At the end of this chapter, what you should know is state the principle of conservation of linear momentum, differentiate elastic and inelastic collisions, and define the coefficient of restitution. Principle of conservation of linear momentum basically means in an isolated or closed system, the total momentum of that system is constant. In isolated system, the total external force is zero. Thus, summation F equal to 0. Summation F is also equal to the rate of change of momentum. So, the change of momentum of that system is 0. Change of momentum is equal to final momentum minus initial momentum as shown in the equation. Then, we will get the total of initial momentum equal to total of final momentum, which is constant. This particular equation is the principle of conservation of linear momentum. The next thing you need to know is collision. The definition of collision is an isolated event in which two or more bodies, the colliding bodies, exert relatively strong forces on each other for a relatively short time. There are two types of collision, which is elastic and inelastic. The most important thing you need to note in collision is the coefficient of restitution or its symbol, small letter ek. The definition of coefficient of restitution is the ratio of the relative velocity after collision to the relative velocity before collision. There are three values of Ek which show different types of collision. When Ek equals to 1, it is elastic collision. When Ek less than 1, it is an inelastic collision. When Ek equals to 0, it is completely inelastic collision. Next, we need to differentiate between elastic and inelastic collision. First, the definition. Elastic collision means one in which the total kinetic energy as well as total momentum of the system is the same before and after the collision. Inelastic collision means one in which the total kinetic energy of the system is not the same before and after the collision, even though the total momentum of the system is conserved. Then, we need to differentiate the properties for elastic and inelastic collision. The total momentum for both elastic and inelastic collision is conserved. So, for both collision, the total of initial momentum is equal to the total of final momentum. For elastic collision, the total kinetic energy is conserved. Thus, the total of initial kinetic energy is equal to the total of final kinetic energy as shown in the equation. For inelastic collision, the total kinetic energy is not conserved but total energy is conserved. So, the total of initial energy is equal to the total of final energy, while the total of initial kinetic energy is equal to the total of final kinetic energy plus the energy loss. The third property we can differentiate is the coefficient of restitution. For elastic collision, the coefficient of restitution is equal to 1, while for inelastic collision, the coefficient of restitution is equal to 0 or less than 1. The figure shows the difference in situation for elastic and inelastic collision. This situation is just an example and it may be different depending on the questions given. The important thing you need to note is the situation after the collision. If it is elastic collision, the balls have tendency to rebound and move in opposite direction. While for inelastic collision, the balls may stick together and move in the same direction. But remember, not all the inelastic collision is stick together.